Virtual reality, VR, has received great attention recently due to the growing application in games and industrial design. Current VR devices require a cumbersome head-mounted display to be attached to a powerful computer. Because of this, users are restricted to play VR in a small area. With the advent of Google Cardboard, users can explore the VR world using their own mobile devices. However, current implementations for VR are restricted by the computing model and must trade off among quality, size of display, and responsiveness. To overcome this drawback, our system integrates ray tracing, cloud-based rendering, and light field as a solution to fulfill the requirements of the three aspects. For example, 3D rasterization is frequently adopted to shorten the rendering time in exchange of rough image quality. Thus, some photorealistic effects such as soft shadows can hardly be generated by this method. In contrast, physically based rendering effects can perfectly be seen in our final view without sacrificing the performance. Specifically, we adopt ray tracing in our system designed to generate high-quality images by simulating the physical light transportation in the scenes. The color of each pixel is a combination of individual cameras' ray being emitted into the scene space. A ray may intersect with an object and generate additional reflected or shadow rays. However, ray tracing is such a computationally intensive task that requires millions of ray to be computed before a single frame is rendered. It is impossible to render a ray-traced image on mobile devices due to the power constraint. In our design, the computing is uploaded to the cloud server. The rendered images are streamed back to the device via network, while the cloud server can continue the ongoing rendering tasks simultaneously. The system adopts a special display technique, the light field display at client side. It can display free viewpoint by interpolating the pre-rendered images. Interaction with scene objects is also possible. Users can add objects to the scene. The server will send the new images back to user devices. With our system, users can experience immersive VR, from usual conference room to majestic Sponza Palace, in a certain level of interactivity.